Alright, so in this video we're going to talk about electrical charge and how things actually get their electrical charge. So we know that charge arises from the movement of electrons or the transfer of electrons from one substance to another. And electrons essentially like to or easily transfer from unlike materials. So we can charge things by contact or sloughing or rubbing things together that have two different compositions or makeups. So if we take wool, which is very different from, say, a rubber rod, and we were to rub them together, then the electrons actually transfer from the wool to the rubber rod, and therefore on the wool we'd have a net positive charge, and on the rubber rod you'd end up having a net negative charge. Now, if we look here, I have an example of a simulation. So here you have a wool sweater, and if I were to take a balloon and rub it, you can see that the electrons are transferring to the balloon. Now, if I release the balloon, after it has picked up some electrons, it is then attracted to the sweater. So this right here is an example of electrical force, which we'll go into more detail later. But opposites attract and like charges repel one another. So because the balloon has picked up excess electrons, it has a net negative charge, and because the wool has lost some electrons, it then has a remaining positive charge. Now we can also bring this balloon over near this wall, and you can see it also is affecting the charge distribution on the wall. So this wall would most likely be made of some type of metal where the electrons were free to flow inside of the material, and so you can see you can end up with a net negative side or a positive side to the wall. Right. Now, commonly this also can be done with something called pith balls, and so pith balls are just you just hang them from a string on the ceiling, and they're made out of some material. Sometimes it's aluminum or something like that. And so if you were to put two uncharged pith balls next to each other hanging, and I guess I'll spell that for you, it's pith. And if they were uncharged, they would have no interaction, okay? But let's say we charged them and we have one, let me draw that again. Let's say when I hung them next to each other, they actually, this number. Now, you would know because they were forcing each other apart that they would have to be like charges, so either both negative or both positive, and they would repel each other. Or we could have another example where they would hang next to each other and they'd actually be attracted. So it would be positive and negative. So this would be unlike charges are attracting, or opposites are attracting one another. So this is an example where we actually can charge up objects and then see how they interact with one another. And you actually play around with this in the lab. Now, another example is charging by something called induction. So induction is a type of charging that does not require touching. So it does not require contact. And so this would be sort of the example of the wall. So if we looked back here, we looked at the simulation again, I bring this object close, and I can actually see that I can affect the charge distribution just by bringing a charged object close to it. So let me sort of give you another example of charging by what is considered induction. So let's say I had a conducting sphere. So a conducting sphere is going to be made up of some sort of conducting material, and so it's going to be made up of metals, and metals allow electrons to move freely through their matter, so with inside. So they allow the electrons to move. So if this is made up of a whole bunch of atoms of some sort of metal, you've got a whole bunch of protons and electrons. And if I were to bring, say, a rod near it, a rubber rod that had been charged and it's negative, I bring it close, I don't touch the conducting sphere, but essentially it's going to force those electrons to one side. So one side would be partially positive and the other side would be partially negative. Okay, now if I wanted to charge that sphere and leave it with a net positive charge, what I could do is then attach that sphere by a wire to a ground, okay, or to the earth. And essentially because the electrons are repelling each other, so they're trying to push each other away, and now that they're connected to something, they have some place to go, right? So they're going to rush off of the piece of metal, and they're going to go and spread themselves out across the surface of the earth, or whatever you're touching here. And so when the electrons leave, now you are left with a sphere that will have a total net positive charge. So that's an example of charging by induction. There's an induced positive charge on the sphere. Okay, so this idea relates to static electricity. Okay, and so let me kind of go back and let me open one other simulation so I can show you. So you may have experienced this before, but as you may say, like walk across a carpet and you rub your socks along the carpet, essentially what you're doing is you are transferring electrons from your carpet and to your person, right? And it spreads out across the surface of your body. And then if you were to come into contact, say touch a light switch or a metal door handle or something like that, then you feel a shock, right? This is static electricity. So as you rub your feet along the carpet, you can see electrons are building up on the surface and they're spreading out as far as they possibly can. And then if you are to touch the ground, they will transfer from you to the earth, and that is where you get that sort of spark that you get if you touch the light switch. So these are all sort of different examples of how we actually make objects charged. And the next video I'll talk about actually how we go about calculating the amount of charge that an object has as a result of electrons moving.